Uh, Actually, I changed the original title of my presentation a little bit because currently we got two case-based reasoning strategies of automatically selecting terrain covariates for geographical variable mapping. And first is the background of the study. For many geographical variables, such as soil property, landslide susceptibility, and the species habitat suitability, their detailed spatial information are very important for the geo analysis, geo simulation, as well as decision making. However, they are hard to be acquired by a direct observation technologies such as remote sensing. So geographical variable mapping through building the relationship between the geographical variable and the environment is normally used way for this information. The very beginning and important step for this task is how to select a proper set of the covariates. Currently, we have a large number of potential covariates for geographic variable mapping. Mostly is terrain covariates, like a lot of curvature, slope, and many other topographic attributes. And currently, we have many tools to calculate each of the covariates. However, we still like clear guidance on which condition each covariate should be used in specific application context. So how about some existing methods of aiding users to select covariates? Some of them depends on explicit general rules. However, such knowledge in many application domains are often non-system and empirical, and so they are hard to be formed as explicit rules. And for an application area, if we have a lot of field samples, and statistical or machine learning methods could be used to select covariates. However, for many applications, especially in the very beginning modeling stage, there are exist a few samples. In this situation, statistical methods often fails. So how to automatically select covariates, especially when there are few samples for application areas? Actually, there are many practical applications conducted by domain experts have been published in scientific papers. And in this case publications, the expert knowledge on selecting covariates were implicitly contained in these publications. So in this study, the research issue is how to use this implicit knowledge on selecting proper covariates, mainly terrain covariates in study to aid the geographical variable mapping. So the basic idea is we use the case to provide a suitable way to formalize those non-system and prior knowledge in the artificial intelligence domain. And when we formalize the different existing case to prepare a case base for a new application, we can use case-based reasoning to find the proper solutions for the new application based on the existing case base. So for each one existing application, the key is to formalize their application context through a set of attributes to quantify the different kinds of factors for describing the application context, such as application target, data condition, and the study area characteristics. And for solution part component of the case, we just record the solution, the used covariates in the application case. So we can prepare the case base. And then we can develop different kinds of case-based reasoning strategy. The first strategy is for each covariate included in K-space, we treated it as a binary classification problem. So we can use a K-space to train each classifier for each covariate. And then we can apply the classifier for a new coming application to decide which covariate should be used for the new problem. So this is, we can call it a classification strategy. And different kinds of classifier like random forest or logistic regression will reform the different concrete methods. The second strategy we call the most similar case strategy. It is more general purpose. Like we can, for each new application, we can calculate the individual similarity on every attribute of a case. And then we can synthesize the case similarity. And when we can choose the case with the maximum case similarity to provide the solution for the new applications. Different kinds of methods to calculating the case similarity will form the different kinds of methods. So basically, currently we have two different strategies, and for each strategy we have at least two different methods, such as random forest methods and the logistic regression methods, and the minimum operator method or k-nearest neighbors method for the most similar case strategy. We conduct a comparison study by taking digital soil mapping as an example, because in digital soil mapping, the terrain covariates are exclusively or even extensively used in digital soil mapping. And when considering the terrain covariates, users need to consider about the data availability. They can focus on the terrain study area characteristics. So we design a case formalization for the digital soil mapping. For each attributes in the case, we need to extract values. For example, for a case from the publication, we can collect the area size, resolution, and some information. And we also use Google's engine to automatically calculating some attributes values, such as relief, standard deviation of the elevation, or some mean slope, and so on. So currently we collect 191 cases published in the digital soil mapping related journals, and a total of 38 terrain covariates used in this case base. We conduct a leave one out experiment for cross-validation. 3 typical evaluation index were chosen for the evaluation, like recall index, precision index, and the F1 score index, to evaluate the consistency between the covariates selected by each method and the interest and those originally used in these cases. We also design a reference method, so-called noise, as to pick those most often used covariates. So basically, it's simulates the behavior of the noise for the digital soil mapping. Here's the experimental results. We can see, compared with the noise methods, the random forest performed the best. Well, with the same strategy, the logistic regression performed the worst. And the two methods with the most similar case strategy performed well and stable. And currently, the case base is highly imbalanced because most of the terrain covariates were seldom used in the case base. Even for such a imbalanced case base, random forest performed well for almost all of the terrain covariates, but the logistic regression performed worst. And considering the most similar case strategy, we can see for most of the evaluation cases, the results from the most similar case strategy performed well with a higher index. And that means performed well, especially for those with higher case similarity. And the lower uncertainty or higher similarity, the more consistent or the better performance of the methods. However, for those higher uncertainty or lower similarity, that means there is no similar case in the case space. So this means that the size of the case space doesn't matter. And we also conduct two practical, I hope I also in time. Okay, I try to finish. We also conduct the practical digital soil mapping applications with soil samples in two study areas with different kinds of terrain condition, different area size, and conduct for the different kinds of soil property for the mapping. Here, we use the two different kinds of strategy and methods to recommend the covariates for the two different digital soil mapping methods. One is the individual predictive soil mapping, and another one is random forest mapping algorithms. And we also compare with those covariates suggested by the digital soil mapping experts' knowledge. Then we can use a field samples to make a five-fold cross-validation. I'll quickly introduce the results. You can see in the first Hershan farm study area, the mapping accuracy with the covariates selected by the different methods generally performed well. The result is close to that from the expert's choice. And for the larger Xuancheng County, the mapping accuracy were much better, even very close to the 0.% to 3% difference with from expert choice. So basically, the mapping accuracy with automatically selected covariates was acceptable for both study areas, while no one single method performed the best at all times. So make a quite quick conclusion. The research issue is how to use those implicit knowledge contained in existing application to automatically select proper covariates. Here we suggest two strategies. The first one is the covariate level binary classification strategy. The second one is the most similar case strategy. And I think we can explore the potential of such case-based reasoning strategies into the intelligent modeling. And some future work, I think the first one is the size of the case-based data matter. And we also try to explore other domain for the application and try to integrate these methods into modeling tools. So thank you. Hope I'm still on time.
You're right on time. We probably have a chance for one quick question. Anyone have a question?